Hello and welcome to G Fun Facts Online, the show where we dive deep into the science and technology shaping our future. Today, we're talking about something straight out of a sci-fi movie, a concept that is rapidly becoming a breathtaking reality. We're exploring the line where human and machine blur, the revolutionary world of bionic limbs. For generations, this was the stuff of Luke Skywalker's hand or the $6 Million Man. But advanced prosthetics are no longer fiction. They are here, and they are transforming the lives of people with limb loss in ways we could only dream of just a decade ago. This isn't just about replacing a missing part. It's about restoring a sense of wholeness, of function, and in some incredible cases, even enhancing our abilities beyond our natural biological limits. We are stepping into a new era, a fusion of artificial intelligence, intricate sensory feedback, and the mind-bending concept of human augmentation. Together, these fields are creating bionic limbs that are more intuitive, more integrated, and more lifelike than ever before. So, get ready as we unravel the technology that is literally reconnecting people to their world. Let's rewind for a moment. For a long time, prosthetic limbs were, to put it bluntly, quite basic. They were often heavy, cumbersome devices that relied on manual controls or very simple, pre-programmed movements. Think of a simple hook or a leg that could only bend at a fixed angle. But that's all changing thanks to the magic of artificial intelligence. We're now in the age of smart prosthetics, and the smart part is AI. At the core of this leap forward is a technology called machine learning. You've heard the term, but what does it actually mean for a bionic arm or leg? It means the device can learn, adapt, and even start to predict what you want to do before you consciously do it. Imagine a bionic hand equipped with sensors that detect the tiny electrical signals in your muscles. As you think about picking up a glass, those muscles twitch in a specific pattern. The AI analyzes this pattern, along with data from past movements and even its environmental surroundings, and translates your intention into a fluid, precise motion. Instead of having to think, okay, now open my hand, now close it around the cup, not too hard, the user can simply reach for the cup, and the hand does the rest, almost naturally. This predictive movement is a game changer. If you always reach for your morning coffee cup with a particular grip, the AI learns this. It anticipates the action and prepares the hand to form that exact shape, dramatically reducing the mental load on the user. But it's not just about hands. AI-powered prosthetic legs are becoming masters of adaptation. They use data from pressure sensors and accelerometers to analyze the ground you're walking on in real time. Whether you're on a perfectly flat sidewalk, a grassy park, or a steep incline, the leg adjusts its mechanics to keep you stable and reduce the risk of falling. In fact, at the Consumer Electronics Show, CES 2025, a commercially available prosthesis called the BioLeg won a Best of Innovation award precisely for this ability. It helps users navigate stairs and slopes with a remarkably natural gait, something that was incredibly difficult with older prosthetics. And the more you use it, the smarter it gets. The AI constantly learns from your unique habits, fine-tuning its responses to make every movement feel more efficient and more you. But where's this all heading? The ultimate frontier is the synergy between AI and brain-computer interfaces, or BCIs. This involves systems that can decode your brain signals directly. You simply think about moving your arm, and the bionic limb responds. AI is absolutely critical here, acting as a sophisticated filter that cuts through all the noise of your brain activity to isolate the specific command, making the control reliable and incredibly precise. Now, moving a limb is one thing, but what about feeling with it? For anyone who has lost a limb, one of the biggest challenges is the loss of sensation. The inability to feel the texture of a cat's fur, the pressure of a handshake, or the temperature of a hot drink creates a profound disconnect. It makes simple tasks, like picking up an egg without crushing it, incredibly difficult. This is where the next revolution is happening: sensory feedback. scientists and engineers are developing incredible systems to transmit these lost sensations from the bionic limb back to the user. One of the most common methods is called haptic, or tactile feedback. Sensors embedded in the fingertips of a prosthetic hand detect pressure, texture, and even temperature. This information is then translated into signals the user can perceive, often as vibrations on the skin of their residual limb. A stronger grip might create a more intense vibration, giving the user a sense of how much force they're applying. But for a truly natural feeling, researchers are going even further, developing neural interfaces that connect the prosthetic directly to the user's nervous system. In a groundbreaking surgical procedure known as the agonist-antagonist myoneural interface, or AMI for short, surgeons can actually reconnect severed nerve and muscle pairs. This allows tiny electrodes to be implanted near these nerves, delivering precise electrical pulses that the brain interprets as real touch. We're talking about users who have reported being able to feel the softness of a pillow or the rough texture of a rock through their bionic hand. This procedure can even restore a degree of proprioception, that crucial, almost magical sixth sense that tells you where your limb is in space without you having to look at it. Think about it. You can close your eyes and still touch your nose. That's proprioception. Restoring this allows for a much more fluid and natural gait or arm movement, as the user doesn't have to constantly watch their prosthetic to know what it's doing. To top it all off, we're seeing the development of advanced materials like e-skin, synthetic skins that not only look more lifelike, but are embedded with a dense network of sensors to detect a huge range of information. The psychological impact of all this is immeasurable. It can significantly reduce phantom limb pain, a distressing condition where a person feels pain in their missing limb. And more than that, the ability to feel a loved one's hand or the warmth of a hug can restore a sense of connection and well-being that is truly priceless. So we've talked about restoring function, but what about going beyond that? This is where the conversation gets really interesting and veers into the territory of human augmentation, using technology to enhance our abilities beyond our biological norms. While the main goal of bionics is therapeutic, the technology is undeniably opening doors to new human potential. Take strength and endurance. Some high-tech prosthetic legs used by Paralympic athletes are actually more energy efficient than biological legs, allowing for incredible feats of speed. In industrial settings, robotic exoskeletons, which follow the same principles, are helping workers lift heavy objects with minimal effort, preventing injuries and boosting productivity. But it could go further. What about new abilities? Bionic limbs could potentially incorporate features that our biological limbs simply don't have. Integrated tools, advanced sensors that can detect radiation or infrared light, or maybe even an extra limb. This isn't just a wild idea. The Third Thumb Project at the University of Cambridge is a fascinating experiment exploring how quickly the human brain can adapt to controlling an extra robotic digit. The possibilities are staggering. We could design specialized limbs for extreme environments, like deep-sea exploration or space travel, where our fragile human bodies are at a disadvantage. Of course, this raises some profound ethical and social questions. Where do we draw the line between therapy and enhancement? As this technology becomes more common, it's a conversation we will all need to have. So where does this all leave us? The progress in bionic limbs is nothing short of remarkable, but there are still hurdles to overcome. The cost of these advanced devices can be astronomical, putting them out of reach for many. Durability, maintenance, and how to power them are also ongoing challenges. But solutions are on the horizon. Researchers are exploring innovations like solar-powered prosthetics, integrating photovoltaic cells right into the limbs designed to keep them charged. As we look towards the near future, say between now and 2030, the leaps will likely become even more significant. AI integration will become so seamless that the limbs will learn and adapt with astonishing sophistication. Less invasive neural interfaces will make that rich sensory feedback and intuitive control more widely available. And the continued advancement of 3D printing will help drive down costs and allow for prosthetics that are perfectly customized to the individual user. We are standing on the cusp of a future where a bionic limb isn't just a replacement, but a fully integrated, sensory-rich extension of the human body. The incredible convergence of AI, advanced materials, and neuroscience promises a world where losing a limb is no longer a barrier to a full, active life, and may even open the door to capabilities we are only just beginning to imagine. Thanks for joining us on Fun Facts Online. We'll see you next time.